Solving a quadratic by isolating the square. So the idea here is if I have a square by itself, I can take the square root to eliminate the square. So when we look at this first example, x squared equals 100, that means I could find x by taking the square root of both sides. That means x will equal 10. However, that's only half of the answer. You see, there are two numbers squared that make 100. One is 10 and one is negative 10. And in general, when we get something like x squared equals 100 and we take the square root of both sides, whenever we take the square root of both sides to solve, we normally put a plus or a minus over there on the other side of the x. So what we say is our answer is plus or minus 10. That means that's really two numbers. It's positive 10 and negative 10. And that is the answer to this question. So we enter this in WAMAP in the answer blank. We enter 10, a comma, and negative 10 because both of those numbers squared make 100. You must have both. Now in this next example, the square isn't by itself, so I can't take the square root. If I were to try to take the square root of both sides now, I wouldn't be able to do anything with this because I can't take the square root of x squared plus 7. It's not a perfect square. So what I have to do is isolate the square. Get the square by itself. So take that equation, x squared plus 7 equals 32, and take a 7 off each side. That'll get the x squared by itself. X squared now equals 25, which means I can now take the square root of both sides. And remember what I said just a little bit ago. When you take the square root of both sides and you solve, you put a plus or a minus over here because there's two numbers squared that make 25. One of them is positive 5 and the other is negative 5. So when we say plus or minus 5, we're saying our answers are positive 5 and negative 5. And again, this is what we enter in the blank. 5, comma, and negative 5. On this next one, same thing. Get the square by itself. X squared minus 9 equals 0. We'll add 9 to both sides. So x squared equals 9. We can get the square by itself by taking the square root. Because there's two numbers squared that make 9, we put a plus or a minus over there. And we say our answers are positive 9 and negative 9. But when we enter it in the grade book, in the answer box, we have to say positive 9 and negative 9 are our answers. Now these are going to start being a little bit weird, and we're going to have square root answers. We've been practicing square roots in preparation for this. X squared plus 6 equals 108. So I'm going to get the x squared by itself. I'll subtract 6 from both sides, and I get x squared equals 102. And we'll take the square root of both sides. And just like we did before, we'll put a plus or minus here because there are two numbers squared that make 102. One is the square root of 102, positive, and the other is negative square root of 102. Now the thing we need to see is, does 102 have any perfect squares in it? Remember how we simplified by taking out perfect squares? So this is where we go to we go and look for factors, and a great place to do that is mathisfun.com. Go to the classroom calendar and look around on the calendar. I put links in there. There's a place where you can generate a table, and we're looking for perfect squares. That is 4, 9, 16, 25, 36, and so on. a list of perfect squares. You can Google that if you need it. But any number times itself makes a perfect square, and I want to find perfect squares in 102. So I went to mathisfun.com and I entered 102 into the factors calculator. And we don't want any negatives, so ignore those. We're looking at 1, 2, 3, 6, 17, 34, 51, and 102. Are any of those perfect squares? No. So I know this thing does not simplify. Which means our answer is positive square root of 102 and negative square root of 102. Now in WAMAP language, we enter SQRT of 102, comma, and negative SQRT 102. This takes a little getting used to, but you'll see it really goes very quickly. There's not a lot of work here, and you need to get used to the idea that your answers can be square roots. And if you plug those in for x, it will make the equation true. Let's try this next one. X squared minus 3 equals 36. We'll add 3 to both sides. We get x squared equals 39. We'll square root both sides. And just like the first examples, whenever we take the square root of both sides, there's going to be two answers. So we put a plus or minus here. And we see that x is positive square root of 39 and negative square root of 39. Now, 39 is 3 times 13, which are both prime. There are no perfect squares in 39. So in WAMAP, we'll write the square root of 39, comma, negative square root of 39. Next example, x squared minus 7 equals 16. We'll add 7 to both sides. X squared equals 23. 23 is a prime number. We'll take the square root of both sides, put our plus or minus for our two answers, and we see our answers are the square root of 23, positive, and negative square root of 23. SQRT of 23 and negative SQRT of 23. Next one, x squared plus 6 is 69. We'll take a 6 from each side. X squared is equal to 63, and we'll square root, and we'll put our plus or minus. Now 63 does have perfect squares in it, because 9 divides evenly into 63. 9 is a perfect square. So I'll write this as 9 times 7. So our x is going to be plus or minus, and I can take the square root of 9 that goes out in front of the root. Don't put it out in front of the plus or minus. Plus or minus is the sign of the number. That goes in the very front. Square root of 9 is 3. That goes out in front of the root. Left under the root is the 7. I couldn't take the square root of that. And again, that's two answers. That's 3 root 7 and negative 3 root 7. And that's what we punch into WAMAP. So 3 times the square root of 7, comma, negative 3 times the square root of 7. A few more here. X squared minus 8 equals 118. So we'll add 8 to both sides. X squared equals 126. And in this case, we might go back to mathisfun.com and see if there's any perfect squares in 126. I entered 126 in the factor calculator, and I discovered that the perfect square of 9 is in 126. So I took 126 and divided it by 9, and I discovered that it was 9 times 14. So now we can use that to simplify the root. So I'll take the square root of both sides and put our plus or minus to get our two answers. And this is 9 times 14. So I see that x is equal to positive or negative. The square root of 9 is 3 root 14. And so in WAMAP, I'll punch in 3 times the square root of 14, comma, and negative 3 times the square root of 14. The last few examples are with bigger numbers. Just again, you're going to need to use that table to find your perfect squares. It just makes life easier for you. But let's do these last three quickly. So let's get x squared by itself so we can take the square root. X squared minus 7 is 125. Get the x squared by itself. So x squared is 132. I'm betting there are perfect squares in there, probably at least a 4. Since 4 goes into 32, 4 will divide into 132. That's actually divisibility rule. If 4 divides the last two digits, 4 will divide the number. So here we have the factors of 132, and looking at the list of positive factors, we're ignoring the negatives. We see 4 on the list, and it's the only perfect square in there. So 132 divided by 4 is 33. 4 times 33. 4 is our perfect square. Take the square root of both sides and put our plus or minus in there. 4 times 33. So x will equal positive or negative. Square root of 4 was 2. 2 root 33. So in WAMAP, it's 2 times the square root of 33 and negative 2 times the square root of 33. X squared plus 27 is 390. We'll take a 27 off each side. 390 minus 27 is 363. Square root of both sides and our plus or minus. And we'll go to mathisfun.com and see what the factors of 363 are and look for some perfect squares. The factors of 363 are 1, 3, 11, 33, 121, and 363. 121, I almost missed it, is a perfect square. That's not an obvious one. It's 11 times 11. So 363 divided by 121 is 3. So now we can use that to simplify the root. So 363 is 121 times 3. So x will be plus or minus. The square root of 121 is 11. 11 root 3. And in WAMAP, we have 11 times the square root of 3, comma, and negative 11 times the square root of 3. Last example. X squared plus 2 is 569. We'll take a 2 off each side. 569 minus 2 is 567. And let's go look at factors of 567. Here are the factors of 567, and you might immediately gravitate to the 9. However, you want to find the biggest perfect square, and 9 is not the biggest. Looks like 81 is the largest perfect square in 567. So 567 divided by 81 is 7. So 567 is 81 times 7. So we'll take the square root of both sides and put our plus or minus. This is 81 times 7. So x will be positive or negative. Square root of 81 is 9. 9 root 7. So it's 9 times square root of 7, comma, negative 9 times the square root of 7.